given with the joint PDF of two random variables x and y, and we've been given a random variable z in terms of x and y, and we've been asked to find out the marginal PDF of z. Alright, so by definition we know that FZZ is probability of z less than z. So first we need to define z. We can partition it in two ways, x greater than y, x less than y. When x is greater than y, of course, we can see that the minimum of x and y becomes y. So it's y plus y upon x plus x whole square, which essentially becomes y squared by x squared. The other term, of course, this becomes y plus x upon y plus x, which is equal to 1. Alright, so we put it into the definition. So FZZ becomes probability of y squared upon x squared less than z given that x is greater than y. For the other condition, we can see that we have assumed that x is less than y, but this cannot be the case because we've been given here that x is always greater than y. So this condition essentially won't contribute much. It won't contribute at all. Alright, so if we try to change this into a plottable line equation, it becomes this. Alright, so we need to plot these two lines. When we plot it, we get this graph. So we need to plot x is greater than y. This turns out to be this particular region. As you can see, it is this region. And we need to plot y is less than z, root zx, which turns out to be this region. Also, we have been given that all things are positive, so we need to integrate this region basically. So we'll take a vertical strip right here, and we'll try to integrate it. Let's see what comes out. Alright, so FZZ becomes f of xy, xy, dx, dy is double integral. Now, we can see that x moves from 0 to infinity, and y moves from 0 to root zx. Alright, so now, applying the Leibniz rule as written right there, what comes out to be is 0 to infinity half z raised to the power minus half x. And in place of y, we again place the value of dz, which comes out to be z raised to the power half x e raised to the power minus x dx. This, of course, cancels this. So we are basically left with the integral 0 to infinity half x squared e raised to the power minus x dx. So I'm going to try to integrate it one part by part. I'll apply by parts here first. This comes out to be x squared integration of e raised to the power minus x minus integration of differentiation of x squared integration of e raised to the power minus x dx is whole integration. This comes out to be minus x squared e raised to the power minus x minus integration of 2x e raised to the power minus x dx. This becomes a plus because of the minus that we get here. Now, I want to integrate this part again. So, okay, let's do that. X e raised to the power minus x dx's integration gives you x e raised to the power minus x. A minus comes here because of this. Minus integration of dx e raised to the power minus x dx's whole integration. This comes out to be minus x e raised to the power minus x plus integration of e raised to the power minus x dx. Of course, 1 minus makes it a plus. This becomes 1. Again, you integrate it, you get minus x e raised to the power minus x minus e raised to the power minus x. I will replace this here, so I get minus x squared e raised to the power minus x plus 2 minus x e raised to the power minus x plus minus e raised to the power minus x. Alright, this becomes minus x squared e raised to the power minus x minus 2x e raised to the power minus x minus 2 e raised to the power minus x. The limits are, of course, from 0 to infinity, as you can see. Alright, so if I put in infinity here, of course I cannot do it directly. So I'm going to apply the L'Hopital's rule written right there. So this comes out to be 0, this comes out to be 0, and this, of course, comes out to be 0. I've differentiated minus x squared's term twice, this term once, and there's no need to differentiate it, of course. Now, when I put 0 here, it comes out to be minus 0, answer comes out to be 2. And of course, we have half here. So the value of this entire integral becomes 2 into 1 by 2, which is equal to 1. So we get FZZ equal to 1, which of course makes sense because this partition is not contributing anything. So that's how you solve the question.